In this example problem, we have an ice skating ladybug of mass 0.5 kilograms and has an initial velocity, or I would say a velocity at point A of 3 meters per second. And at point B, that same ladybug has a kinetic energy of 50 joules. So we can think of point A as the initial and point B as the final. And we want to know what the work done between A and B is. Alright, so at point A, we have a certain amount of information. So at point A, we know that the velocity is 3 meters per second. And we want to start thinking about our initial and finals as moments in time. So at this particular moment, this is the state of the ladybug. And at some later point, point B, we know some other information about a different state. So we know the kinetic energy at point B, which is 50 joules. So sometimes that time also corresponds to a position, but a lot of times we have to think about it in a moment of time, and you'll understand why when we get into later problems. Now, there are a couple different ways of solving this problem, so I presented here the method that I chose to use, because our ultimate goal is to use the work energy theorem, and the work energy theorem is equal to the change in kinetic energy. And we know the kinetic energy is equal to 1/2 mass times velocity squared. So we either have to have the kinetic energies at point A and point B, or we have to have velocities at point A or point B. So I chose to find the kinetic energy at point A using the velocity at point A. However, you could have chosen to use the kinetic energy at point B in order to find the velocity at point B. And then you could have used the full version of the work energy theorem in order to establish what the work done is. Either method will get you the same answer. So I found the kinetic energy at point A to be 2.25 joules, and I know that work is equal to the kinetic energy final, or at point B, minus the kinetic energy initial, or at point A. So I took 50, because that was the kinetic energy at point B, minus the kinetic energy, or the 2.25 joules, at point A. So the work done would be 47.75 joules.